This presentation will show you how to turn your motion applet into a perpetual motion applet. In other words, your ball will keep going. We'll focus our attention on the run method in the main applet. This is what it looks like so far. You've already accomplished this, so let's take a look more closely at where the motion occurs, which is inside the for loop. You'll recall that our for loop will make this program loop 100 times, each time adding 4 to x and 3 to y before updating those values for the game box to redraw. Here's what we'll do to make sure that we can run this applet perpetually. First, we'll introduce a Boolean variable called keep going and set its value to true. Then we'll change the for loop to a while loop. While keep going. In other words, as long as keep going has a value of true, this applet will continue to run and make x and y change and then update them in the game box. Later, we'll find ways to look at certain conditions inside the while loop for making keep going have a value of false. We'll use that idea to terminate a game when we create our Pong game. If you run this program with these two changes, you'll find that the blue ball will move from left to right diagonally going down the screen until eventually it continues and disappears off the screen. The only way to stop it at this point will be, of course, to close the applet. Now we'll introduce another key idea for making this work. Before we had x plus equals 4 and y plus equals 3. Now what we will do is declare two new variables. They're at the bottom of the applet where we have int x equals 10 and int y equals 10. Now these two values, x equals 10 and y equals 10, were the starting point for the motion of our ball. We're now going to introduce two new variables called dx and dy. We'll set dx equal to 4, dy equal to 3. That way, when we go x plus equals dx and y plus equals dy, we'll use the variable values to pretty much accomplish exactly the same thing we were doing with the constants 4 and 3. In other words, x will still get a value increase of 4 each time the loop runs, y will still get an increase of 3 each time the loop runs. Again, if you run the program, you'll get the same result you just got with the while loop and the constants. The ball will go diagonally from left to right down the screen until it eventually disappears. Okay, on to the next step. First, what we'll do is we'll comment out x plus equals dx, and we'll focus our attention only on the y direction. If you run the program when it looks like this, the ball will simply start at the top and go straight down until it disappears off the bottom of the screen. To make this ball bounce up before it gets to the bottom of the screen, we have one more new idea. We'll introduce an if statement that says if y is greater than or equal to 300, dy times equal negative 1. In other words, we'll multiply the value of dy by a negative 1, but only if the y value is greater than or equal to 300. In effect, we'll change a positive 3 that we had as our initial value for dy to a negative 3, which means that every time we add dy to y, it'll get smaller, not bigger. In other words, y will decrease by 3 instead of increase by 3 like it did before. This will have the effect of making the ball appear to start moving upward after this occurs. It will then move upward and keep moving upward until it disappears off the top of the screen. So, what do we need to do? We actually need to add one more if statement, and I'll leave that to you, because we need an if statement to make it bounce back down from the top. Remember, we started out at y equals 10. That might be a good hint. That way we keep changing the value of dy to plus 3 to minus 3 to plus 3 to minus 3 when it approaches these boundaries. It will give the illusion, when we do that, of the ball bouncing up and down between the two boundaries, one at the top and one at the bottom. So, once we get our ball to appear to bounce up and down in a vertical direction, we should go back, uncomment the x variable, and write two if statements so that we can see the ball bouncing in the x direction. Now, x and y are independent, so it'll keep bouncing up and down. It'll add the x direction and give us the illusion of the ball bouncing around the box diagonally. When this is complete, we can draw a box around that movement so that it appears that the ball is bouncing inside the box. If you do a draw rectangle, you can do the box after the fact. If you want it to bounce around in a different colored solid box, you could use fill rectangle, but remember, this is a paint program. You would have to do that prior to the motion. Okay, now let's look at how we might refine this idea. Remember when we draw the ball that we draw it from the upper left-hand corner where we have an x value and a y value. And then the ball is 30 pixels wide and 30 pixels deep. Now, we have to pay attention particularly to the bottom boundary and the right-hand side boundary when we're using our if statements, because we have to take into account that the x value is not what bounces off the right wall and the y value is not what bounces off the bottom wall. It's x plus the width of the ball on the right and y plus the depth of the ball on the bottom. Take this into account, make some adjustments, and when you're finished, you'll have a perpetual motion applet, a ball that continues to bounce all around your box with nice, clean collisions on the wall. All right, let's give it a try.